Hello everybody. Now we talked about finding out a course and distance, and we talked about it will depend upon the track a navigator will choose. And the tracks we talked about was rhumb line and great circle. And in rhumb line we'll be talking about parallel sailing, plain sailing and Mercator sailing. But before we get on to parallel sailing, let's at least get clear about what is rhumb line and what is great circle track. Now we know that the shortest distance between 2 points is a straight line. And what exactly is a straight line? A straight line is a line which will make a constant angle with some reference point. And on Earth, we take north as a reference point. And as you can see here, this line is making equal angles with north throughout. In contrast, a curve would make different angles with north, which you can notice here. All angles with north are different. On the surface of the Earth, 2 points, the shortest distance should be a straight line. But this straight line, as we can notice, that these angles are not equal. So this shortest distance between 2 points on the surface of the Earth is not a straight line, but a curve. And we talked about, when we talked about great circles, we said that it is always possible to draw at least one great circle to two given points on the surface of the Earth or sphere. Now the arc of this great circle would be a shortest distance and would be as good as a straight line, what we can see here. Now, if you are sailing along this straight line as shown here, which is making different angles with the meridians, that means as your ship is crossing the meridians, your course will have to be altered. Then you are sailing along a great circle track. In contrast, if I tried to make a straight line here, which is an angle of 90 degrees I'm trying to make here, you will notice that this straight line turns out to be a curve. And this curve is spiraling towards the pole. Of course, it doesn't go and meet the poles, but it is tending to curve towards the pole. Now, this line, a curved line, what we make on the surface of the Earth, which is cutting all the meridians and at the same angles, 90 degrees, what I'm showing you here, is called a rhumb line track. And a navigator prefers to sail along the rhumb line track, as we just noticed that in great circle he'll have to alter course on and off, whereas in rhumb line he can maintain his course of 90 degrees and reach B. Now when you're sailing along your latitude or latitude, that would be a rhumb line track as well as a parallel sailing. If you're sailing along the meridian, you are making an angle of 0 degrees. So that's a rhumb line. Rhumb line is which is making same angles with all the meridians. Similarly, if you're sailing along a parallel of latitude or equator, that's also rhumb line, because you will be always making angle of 90 degrees, or your course will be 90 degrees or 270. Now, parallel sailing was done earlier when there was no means of finding out what was the longitude. So normally that time, olden time, the sailors used to sail either north or south till they reached a particular latitude, and then they used to head east or west to make landfall. So the course used to be 00 degrees, 180, 90, 270. So sailing was parallel to either meridian or to the latitudes. Now we don't do this. Today, this parallel sailing is merely used only for finding out the east-west distance between two meridians, which we call departure. Now this is important for us to know what is the difference, what is the distinction between D.LONG, departure, because you keep on converting your departure into D.LONG or D.LONG into departure quite frequently. So this should be clearly understood what is the distinction between D.LONG and departure. There is a trigonometrical relationship between departure, D.LONG, and latitude, which can be proved. So if I'm drawing this triangle just to show it to you here, triangle PAB. I'm drawing the second triangle here, PCD. You think they're similar? Anyway, you know better about geometry, similar triangles, how they're similar, that you'll figure it out yourself. And in similar triangles, the sides are proportional. Looking at the Earth from above the pole, you will see the equator, which is a great circle with the largest circumference. And then you'll see small circles parallel of latitudes, small circles with smaller circumference. Now you look at it here, they are concentric circles with P being the center, and P being the center means along the axis. Axis is your center for these circles here. And I've just drawn these meridians. And we know that when you have concentric circles, then the arcs of the circle would be proportional to their radius. So arc of the circle, that's your CD and AB, are proportional to the radius. When you are measuring it along the equator, between 2 points, we call it D.LONG. And when you are measuring it along any other parallel latitude, it is departure. So here it is departure by D.LONG along with all the radiuses here. Here C is the center of the Earth, and 2 points on the equator. So when you are measuring it, the arc of the equator, that is called D.LONG as per the definition of D.LONG. And CA and CB are the radius of the Earth. Now D is the center of this parallel of latitude here, and DE and DF is the radius of the circle, the parallel of latitude, and E to F, the arc of the latitude, is defined as the departure, the east-west distance between two meridians on any other parallel of latitude is departure. We know that the plane of the equator is 90 degrees to the axis, so this angle will be 90, and this is being parallel to the equator. This angle also will be 90 degrees, corresponding angles. Being concentric circles, the arcs will be proportional to their radius. So I put it down here, arc EF divided by AB and the radiuses. So this arcs are departure and D.LONG is equal to your radiuses here, proportional to the radius. Now this C to E, that's also the radius of the earth. And angle ACE or BCE is the latitude of E. Latitude is angle at the center or arc of the meridian contained between equator and parallel of latitude here. So this angle is your latitude. Can I replace CA here with CE because they both are the radius? So I have just replaced CA with CE, which is the radius of the earth again. Now I have got this triangle BEC, which is a right angle triangle. EDC, this was 90 degrees. So this is 90 degrees. This is your right angle triangle. This was 90 degrees. So angle remaining C is 90 minus latitude. 90 minus latitude. Now in this triangle, being a right angle triangle, E to D is your perpendicular. This is your hypotenuse. And perpendicular by hypotenuse is sine of theta. That is sine of 90 minus latitude here. So departure by D.LONG is equal to cos of latitude. A important relation between between departure, D.LONG and latitude. Now if you go look at this formula here, we've been talking about it, that the east-west distance between two meridians is called the departure. If you look at the equator, cos 0 is 1, so departure is same as D.LONG. So at equator, if the 2 points are on the equator, the D.LONG is also the distance, east-west distance between the 2 points. Whereas on any other parallel of latitude, D.LONG is not equal to the departure. Departure is D.LONG into cos of latitude. So this is something which has got to be very clear in your mind. Some questions here just to explain this. Now ship is sailing due east and distance is given to us. What does sailing due east means? That means you are going along the latitude. So that once you're going along the latitude, that distance would be your departure also. And the D.LONG is given to me as 5 degrees 26 minutes. So I can find out what latitude I was in. And here I have used the thing north and south because it is possible in both the hemisphere on this particular latitude. Similarly here, distance between two meridians, that is the D.LONG now is 10 degrees and they are in parallel of latitude 38 degrees. So D.LONG is 10 degrees between them, but the east-west distance would be different. That is your departure. So you can calculate your departure, the east-west distance between them by using this formula. Departure by D.LONG is equal to cos of latitude. He says, in what latitude will the number of minutes of longitude be double the corresponding miles in departure? So let us consider departure to be x and the D.LONG has to be 2x. So what is my latitude? 60 degrees north or south. Here It says a vessel is steaming due east at 20 knots for 2 hours. So when it is steaming due east, that means it is going along a latitude. So the distance covered by it is your departure. So that is 40 miles what she has done due east. That is your departure. D.LONG has been given to me as 1 degree. That's 60 minutes. And this is my latitude here. North and south because possible in both the hemispheres. It says in what latitude will the speed of rotation of Earth be 40 knots slower than that at equator? Now we know that the Earth rotates, goes round 360 degrees per day. You can see here, suppose the observer was here, sun is here, it's on your head. So in a day, the Earth moves west to east and takes a turn of 360 degrees to be back here. So the amount of longitude what she has covered is 360 degrees in 1 day, and the rate of change would be 15 degrees per hour, which in minutes is 900 minutes per hour. Now D.LONG at the equator is also the distance what she is doing, Earth is doing. So the equator would be moving at the rate of 900 miles per hour, and that is what is your speed per hour. He says what latitude would the speed be? 400 knots less. That means the speed should be 500 knots. So the east-west distance covered by the Earth in 1 hour, 500 knots. This is your departure. And your D.LONG, irrespective of what latitude was your D.LONG was the same in 1 hour, 900. So your latitude, in which the speed would be 400 knots less than that at equator, is 56 degrees 15 minutes north or south. We'll continue with more problems on parallel sailing next. Thank you very much for being with me.